So good evening, everyone. My name is Florian. Like Amir said, I'm RISC-V ambassador and sales manager for Andes Technology. And it's my pleasure to be on the third RISC-V meetup in Israel. Also, it's just a virtual meetup. So I hope in future we also can meet face-to-face when everything cools down. Today, I want to talk about AI and how you can scale from edge to server with RISC-V and also use Linux. My agenda, I want to first give a very quick introduction. Who is Andes Technology, in case someone didn't hear of us, but I believe everyone knows us. Then I will go a little bit more into RISC-V, where it is used, and also give some possible sample applications and some real-life applications. I will introduce quickly our vector, which is the vector for everyone, pretty cool, and then have some more technical look into our RISC-V course. So let's get started. Who is Andes? So first, we are a pure P company, but we are also a RISC-V founding member and a premium member. We are also listed on the Taiwan Stock Exchange. So we are a Taiwanese company. So that means we are a public company. And we are also a major open source contributor and maintainer. Like U-Boot, GCC, LLVMs, that's where you can see us. We're also running various task groups. For example, we have donated some of our own in-house ISA, the P extension, which is a DSP SIMD extension to RISC-V. So we are running and cheering the task group. We are also working in the vector task group. So we are pretty engaged at RISC-V because we think RISC-V is really the future. Some quick facts about the company. So we are now 15 years old. We just had birthdays this February. Worldwide, we have over 200 licensees who are actively working with our course. As I said before, we are a pure play CPU IP company. So over 80% of our employees are in R&D. And we have now, or our customers, I have to say, have now shipped over 5 billion devices with our course embedded. Very proud, since 2018, each year we have 1,000 devices and above. And we also have our own integrated development environment. We call it Andes site. Here we are having a worldwide installation base of 17,000 installations, which we are also maintaining, updating, and so on. For our location, like I said, we are a Taiwanese company. So our headquarters in Hsinchu, Taiwan. Hsinchu is the Silicon Valley of Taiwan. We have dependencies in China, of course, in US. We are in Europe, like Netherlands, France, but also Korea, Japan. And of course, we are in Israel. In Israel, we are working with our sales rep, Beyond Electronic. So Yossi or Menachem, the go-to people in Israel if you need a RISC-V core from Andes. Like I said, we are pretty involved in the RISC-V. So just to name a few roles, on the left side, you see the RISC-V board members. That is our CEO, Dr. Frankwell Lin. Then our CTO, Dr. Charlie Su. He's the vice chair of the technical steering committee. And we also have a RISC-V ambassador, which is myself. So we are pretty engaged and not just selling some RISC-V product, but actively contributing, trying to make things better, and also promoting RISC-V. That's why I'm here today. Let's check a little bit more about the market adoption and look at some usage examples where RISC-V is used. So let's start first where we are in Andes seeing that RISC-V is used. And actually what we are seeing is that RISC-V starts from microcontroller units or even FPGA implementations, but it goes up all the way over blockchain applications, multimedia, security, up to autonomous driving assistance systems. But we also see it strongly in wireless, SSD or 5G macro cells, and even in data center where you have AI accelerators. Another interesting point we see about RISC-V is the number of cores. So in the microcontroller unit MCU, we're seeing customers using 1 core, but if you're going up like AIoT or also in direction of multimedia, customers using up to 10 cores. For example, in an SSD, we have customers using 30 cores, even more. And then if you go into the data center and the AI accelerators, we have customers who are using 100 cores or even up to 1,000 cores. Another interesting thing with RISC-V we are seeing in Andes is that RISC-V is not for some old nodes. Actually, the opposite is true. RISC-V is, from our experience, ranging from 14 nanometer down to 7 nanometer. Right now, we even have a customer who is considering to get the latest node from TSMC. So that's kind of surprising to us because RISC-V is in 7 nanometer. We have a customer for data center with over 100 cores utilizing them. That is really leading or bleeding edge technology, and RISC-V, that means it's really a good sign of quality for RISC-V. I have to say, most of the applications we are seeing for RISC-V is somehow AI related. So image analyzing, voice control, 5G macrocells or something, it always goes into AI. If we are looking a little bit on the trend of RISC-V, so first the general purpose, and in general there was ARM. And when RISC-V came, RISC-V was first used in the deeply embedded, cost-sensitive things like replacing finity state machines, make it a little bit more programmable, or adding RISC-V for some housekeeping tasks. Then we saw people moving on for DSP and maybe adding some vector, but ARM was still there. However, what we are seeing recently in the last 6 to 12 months is that RISC-V more into this ARM-dominated regions where you really have high-power microcontroller unit, the big little principle or so. So RISC-V is getting more and more stronger and really pushing up into the general purpose and performance-driven applications. All right, let's have some example of an edge computing. I choose here vision processing. So please don't take everything for very granted and 100% accurate. It's more like an example to give you some ideas how you can do it. The blue boxes here, that's what Andes can supply. The gray boxes, if you're building an SoC, that's what you would source from some third party. So you would have in an edge device, you can have a control core like the A25MP from Andes. It's a multiprocessor which can run Linux. Of course, you would have some DMA. And then if you have some vision processing, you can choose an Andes NX27 vector, for example, with a vector length 256-bit. And you also can add some neural network processing unit. You can add your own accelerator. You can add a third-party accelerator, or you even could use an Andes processor for this. So that's just an idea to show you there is not only one core, and if there are multi-cores, how do you use them in a typical SoC? Let's make it a little bit more real-world example, something we have implemented. So one of our customers was using Andes technology in a TWS, in true wireless stereo earbuds. That's the hearing things, like Apple has a lot of them on the market, and there are various other people who kind of have similar products. So this customer already has taped out, and it's one of the first products to support LE audio and classic audio. The customer has chosen Andes because we had excellent power, performance, and area. We could support various real-time operating systems, not only FreeRTOS, but also ThreadX, AliOS, and many others. So that was also an important step for the customer. And then with the DSP extension, he got outstanding performance with a good library, easy to use. DSP, I will go later a little bit into the detail. Just to let you know, we do have, like, for example, algorithms for noise and echo cancellations. They're excellent for this. But also if you do want to do something like machine learning, like keyword spotting, that's extremely well done for the DSP processor. Okay, after we have looked into the low power, let's look a little bit into the data center area. So here an example of an cloud computing, like you would use it in a data center. Imagine this as an open compute card or like some PCI Express card you're putting into your server. You may have some interface to the outside world like PCI Express. You may have some onboard SRAM for storage and also some DDR interface. And then your data processing, what we see, people choose a main CPU, 7 MP, it's a 64-bit or the 45 MP. And this is interacting with the PCI Express interface, getting the data, partitioning the data, and then getting the tasks for the number crunching and what need to be processed to other cores. Like in this case, again, the vector processor, multiple cores of them, not only 4 like here, but up to 100 or even more. And then the second thing is what we are seeing, some people adding a second accelerator, kind of a neural processing unit, which also could be standalone. And again, what we see, you mostly have a coordination core, which is doing the internal coordination, which helps the customer to abstract the complexity of having many cores inside, which are for number crunching. And this coordination core then would take the data and forward it to different controllers, which can do the task by themselves, or which even can break down the tasks and put it to different accelerators. So that is very rough, just to give an overview when I talk about many cores, how they are used, what we are seeing for trends, just to give you some rough idea about it. The next point I want to show is the RISC-V. So why would you go for an embedded vendor like Andes? Firstly, Andes, we do have some baseline extensions that is to help you speed up memory access and also branches. Then we have a feature which is Codense. So if we are using Codense, we get 12% better code size measured by GCC. So the standard RISC-V GCC compiler compared to our Codense is 12% bigger. And especially in IoT devices, if you have a lot of memory, it costs a lot of money. So if you can reduce it by 12% and you produce a few millions of this SoC or IoTs, that can save quite some money. But then there are also other things like power break, which can help you to save power by stalling the pipeline, for example, and waking up on events or interrupts. But also things like stack safe, which helps you to protect your stack. So it throws an interrupt if you're going over a defined stack level or under a defined stack level, or it just can help you to monitor what is the maximum size of your stack. So it's especially handy when you're developing it. And then we also provide something like vectored platform level interrupt controller, which is great for preemptive behavior, and it also can reduce the latency by 75%. By the way, so things like the vectored PLIC, we're also trying to co-work and working in the committees with RISC-V to update this and bring these advantages we see also to the wider community. So all these features Andes is offering are powerful features which can help you to differentiate your product and get a competitive edge compared to your other competitors. Another thing is what I mentioned before is the DSP extension. It's also known in RISC-V as the P extension. So that is a packed SIMD or DSP extension. And it was actually developed here in Andes. We used it for our own RISC products. So before RISC-V, we had our own quite successful controllers, very low power. And this was the P extension or DSP SIMD we used to accelerate slow video like face detection or audio and voice keyword spotting and low data rate DSP workloads. If you're looking on some real-world examples where we measured on a device which has the P extension and we compiled the program one time with P extension and one time without, So on a 32 bits that are the green bars for an AMR voice codec like in mobile phones, we can speed up by 3.7 times and keyboard spotting like 5.7 times. If we are measuring on a 64-bit systems and we have a face detection using a PIN, a speed up from 8.9 times. And Cipher 10 image classification, like what is in the image? Is it a house? Is it a car? Is it a horse? That can be speed up by 14 times. Like I said, this P extension, we have contributed the ISA to RISC-V, so now our others can also implement and leverage this. And also another advantage of the P extension is that it's using the general purpose registers from the RISC-V. So there are no new registers, it's this general purpose register, which makes the programming and the maintenance of the programs also a little bit easier. So last but not least, we have a cool feature which is called NS custom extension. So with RISC-V, you have the possibility to add your own custom instruction that is defined via the domain-specific acceleration space. Sorry. So our ACE, the NS custom extension, can help you to add this very easily. What we are providing here is a tool called Copilot. And with Copilot, you just define your function, like the hardware RTL in Verilog or VHDL. You define some behavior in C code, like for a simulator, and you can give attributes. So attributes can be scalar or vector, it can be background, it can have wide operands, custom registers, custom ports even, and you give all this input to our tool Copilot. And then the Copilot will generate extended RTL, extended instruction set simulator, and also extended tools for compiler, assembler, and disassembler. And the most helpful thing, it will bind this extended RTL and instruction set simulator and everything with the NDIS supplied RTL. So that means you can take a CPU core, you can make your custom extension, but if you're using the NDIS custom extension, our cool tool Copilot will take a lot of the work, and instead of spending several man-months to implement this, you can implement it very easily in a few days. So that is really a big advantage. Copilot is actually like an EDA tool which let you design your own custom extensions. All right, let's have a short look on our roadmap. As you can see, it's quite comprehensive. So we are starting with our N22 on the left lower side. So it is a two-stage controller. On the right side, the frequencies you see, so that is worst case frequencies in TSMC 28 HPC plus process. And yeah, up to 700 megahertz, a two-stage controller. Then our, I think I would call it workhorse, the 25 series, starting from the N25F, which has floating point unit and of course physical memory protection, ranging over the D25, which has additionally an DSP processor, and then up to the A25, which comes with memory management unit in case you want to run Linux, and up to the MP version. MP stands for multi-core, multi-processors. So here you also have an L1 and IO cache coherence, as well as L2 cache. All of these versions, well, except for the 22, but 25, 27, and 45, they're available in a 30-bit version, or with the X, it will be a 64-bit version. The 27 series is based on the 25 series, but we have done enhancements for the memory. 27 comes with a vector, and also the A27 and A27MP will have possibility support for vector. And then last but not least, our 45 series, it's a 8-stage dual issue superscalar design, also ranging again from a fast and compact series over the DSP extension, Linux capability to multi-cache coherence. The 4 boxes in red, that is under development right now. The boxes in black, that was what is available today. Okay, let's have some look onto our vector. So the vector is a grayscale style scalable vector processor. It is open, so that means the ISA for the vector is open. That means you have a big community who is contributing, who is working on this. There is extensibility. For example, we have added some vFloat 16 and in 4 for AI training. It is scalable, I will show you, so you can configure it for your need. It has great performance, much better performance than the standard one, and it's very efficient. And then last but not least, there is also visualization. That means we are providing a tool which let you visualize the pipeline, so you can measure the performance. You can see if you have bubbles in your pipeline, or if your pipeline is stalling, and then you can analyze why, and you maybe can rearrange instructions to make it away and have 100% utilization of your vector. So you can see, and this vector, we are providing quite a good ecosystem and a lot of add-ons. The vector itself, like I said, it's here on the NX27B. The vector is one product, but the big advantage from my point of view is that the vector can be configured. So once you have decided you want to have this vector unit with RISC-V, you get the vector, and you get a graphical user interface tool where you can set the vector should be 512-bit, 256 or 128. Then you can synthesize your design and see if the performance is enough or not, and you can readjust this. So that makes it very easy and very independent. So you don't need to come to Andes and ask for changing something. You can do it immediately by yourself. Looking just on some of the things. So first, we think we have to our knowledge, the first RISC-V vector engine, which is shipped in the industry. We are already in mass production a while with the 0.8 version. Right now, there's the 0.9 version, so we are updating this. That's not a problem because we will support our customers to update and also help them to maintain the older version if that's needed. Like I said, optimized it with vFloat 16 and in 4 because that's some requirement we have seen in the industry, especially for machine learning. The space for it, just if you're interested, I give you some details. In a TSMC 7 nanometer FF plus process, we can reach 1 gigahertz worst case frequency, and the area would be 0.3 square millimeter. It's configurable and scalable, like I have said before. It has very low power and is simple to use. For example, we have implemented multi-level clock gating and also in order one read-write SRAM cell-based structure. So it makes it more usable for you and takes a lot of headache out. If you're looking on one example, like if you would take 50 of this vector processing units, you still could fit it in a SoC and manufacture a open compute card or PCI Express card, which has a power consumption smaller than 10 watts. Okay, let's jump a little bit more into the course, give some technical details. So let me start with the 25 series. The 25 series can be configured as 32-bit or 64-bit core. It is the RISC-V architecture plus the Andes extension I have mentioned, like smaller code size or stack safe and all these things. It has optional floating point units, so you can configure it as single or double precision. And it also has optional the memory management unit in case you want to run Linux. The whole processor is a 5-stage pipeline, single issue. There's also a configurable multiplier, so you can configure it, for example, to be very fast, but have a very big gate count, or you could configure it to be maybe a few clock cycles slower, but have a smaller clock count. When I'm talking about configuring, and this is providing also for the course a graphical user interface, which allows you to adjust the core. Like you can say in the graphical user interface, I want a small multiplier or I want a fast multiplier. You can enable single for the floating point unit, single precision or double precision just by a click. Most important, this graphical user interface is configuring our RTL, and our RTL is all handwritten in Verilog. So that allows you to really inspect what is ongoing in the RTL. That makes the debugging more easier because you can trace through the RTL. You see all our labels and so on. So this graphical user interface tool I mentioned is more or less just configuring this Verilog and setting defines to achieve the desired outcome. So it really just helps you to save time. The 25 series also has instruction and data caches as well as local memory. There is optional parity or ECC protection. Again, you can switch it on in the graphical user interface, especially if you go for high-end nodes. ECC protection is quite handy. We're supporting hit under miss caches and hardware unaligned load store accesses. The bus interface is AHB or AXI. Again, you can configure this, and you'd also have optional slave ports, for example, for the local memory. So you can, over the slave port, already preload your memory and start it earlier. So in the 25 series, this basic core is also used in the multi-core. In the multi-cores, and we will also have the platform level interrupt controller and the debug support, of course, following the RISC-V spec. On the bus interface, we will have the L1 caches, which are also coherence. And then we also have Andes coherence unit, which is implementing a messy-like cache coherence protocol. And the size of the cache controller can range from 0/128 up to 2 megabyte. Okay, last but not least, so the cores, what I just have said, so this is in the pink box on the left lower side. But last but not least, we are also providing some basic AXI AHB bus metrics, DMA controller, if you like, and also some APB bridge with some simple IOs like quad SPI, I2C, GPIO, real-time clock, watchdog timer. So that is really, if you want to make your SoC, if you have your idea and you need some GPIOs or quad SPI, but you don't want to reinvent the wheel, you can also license this from Andes. And then last but not least, we also have an FPGA board to make your integration more easy and more smooth. Looking on the 27 series, the 27 series is based on the 25 series. We have made the 27 series to especially speed up or improve 3 regions. That is the instruction and data cache, as well as the bus interface unit. So because the 27 series is made to take care of the vector or to be part of the vector, we saw the need for having higher memory throughput. That's why we have modified instruction, data cache, and bus interface unit. And what we are seeing is now that we have around 200% higher bandwidth and 50% lower latency. Of course, that also has increased the gate count and the power consumption. That's why we're still offering the 25 series in case you don't need this high performance, in case you don't need vector, and you're really looking for a gate count or power performance. Okay, so in the 45 series, it's an 8-stage in-order dual issue CPU. Again, MMU for Linux application. Actually, so it's perfect for Linux application. Like I said, it's a dual issue, so most instruction pairs, of course, not everyone. So like also in other CPU designs, some cannot pair together. Some nice thing here is that we have late ALUs, which allows us to have a 0-cycle load use penalty, as you can see here, the first and the second row. And then we also have the memory boost to improve the memory subsystem, as well as we have low power dynamic branch prediction, again, unaligned data access, and of course the multiplier can be configured. All right, time to market. How can we help you to speed this up? Like I said before, Andes is providing our IDE, which let you write your software, debug directly on an FPGA board, or debug in a virtual simulator your SoC. So while your hardware guys still defining the SoC and making the RISC-V product, the software guys already can start writing software for it. Pretty cool, actually. The FPGA boards I mentioned, that's where you can have the course running on it, develop your course at your own hardware accelerator, and these boards can also connect directly to our Andes site, so for easy debugging. Last but not least, we are also providing our debuggers like USB to JTAG debuggers. And then, of course, we have AndesSoft, which is a software stack ranging from bare metal demo projects, for example, how to use GPIOs or watchdog timers, just to help you to make it more easy, and then over different real-time operating systems up to Linux BSP. So of course, you don't need to use our hardware. You can use it. You can get everything from us, and it can speed up your development. But, and that's the beauty thing of RISC-V, you also can use others. For example, one of our good partners, IR Systems, they are supporting RISC-V in their embedded workbench. They have the debugging like the iChat probe where they are supporting RISC-V. And just last week, there was a press announcement, I think, end of last week, said IR Systems is also supporting the P extension, like the DSP and PACT-SIMD extension. So you can see with partners like this or with many people in the RISC-V ecosystem, you are not having any vendor lock-in. You're really free to choose other IDEs, like the IR also has functional safety for their tool chains or C-stats. That really gives you a big flexibility and let you choose different things. That also brings me to the end of my presentation. So for the summary, what we are seeing here and what I also see is that RISC-V is fastest growing. So we believe it will be the future of SoCs because it's efficient and extensible architecture for all computing devices. And because it ranges from very different things like microcontroller units to number crunching vector processors or back to Linux ready cores. So that really gives you a lot of flexibility to configure this RISC-V for your specific use case, for your specific idea, and therefore allows you to have advantage over others by being very specialized, but still following the standard. And here in ANDS, we are committed to serve this emergency RISC-V demand. We have the most matured offering for RISC-V processor IPs, we believe. We do have strong development tools and software from Andes and from our partners, like I could hopefully show you. And our course already used and taped out in various applications like wire security, microcontroller, and also AIoT. So if you're planning a commercial product, I hope you're considering Andes course for your next SoC project. That was my presentation. Thank you very much. Are there any questions?
So I see there are 2 questions. I guess you can see it in the Q&A.
Ah, yep, I see it.
Great.
Okay, so the first question is on which benchmark you got the improve of 12% in dense for GCC, and on what was the GCC version to be based on? Oh, that's a good question. So the benchmark we used for this was CoreMark. The GCC version, I'm not entirely sure. I think the GCC version was something like version, sorry, I cannot say the version. That's something, if you can contact us, you see my email here, then maybe we can answer you this later because I don't know it, sorry. The second one is the generation of extensions. Will it generate a compiler usage for it? And if so, will it integrate it with the mid-end optimization passes or just give a usage for the ASM instruction bin utilities? The generate extension, will it generate a compiler issue for it? So I believe this question to the direction of for our Andes custom instructions. What happens if the customer makes an instruction for the Andes custom extension? Yes, our tool will generate extensions, plugins for the compiler. So the GCC compiler, you can add this plugin, for example, or also for LLVM. And then you will have an intrinsic function which you can use to call this function in your program. I hope that could answer the question. Are there any more questions right now? Oh, I heard yes, the question was answered. Great. Okay, I don't see any more questions. That means my introduction was hopefully useful and also very concise and coming to the point. Thank you very much for listening. And yeah, contact us if you need a RISC-V core, and I give back to Amir. Thank you.